Imagine an AI model that performs like the absolute best, but costs just a tiny fraction of the price. That's the kind of shocking reality of DeepSeek, this Chinese large language model reportedly launched in 2025 that's already, well, shaking up the entire AI industry.
It really is. It's fascinating because DeepSeek is getting this nickname, the Pinduoduo of AI. Pinduoduo being the ultra-low-cost disruptor.
Right, the price just butcher label too.
Exactly, and it directly challenges this foundational idea, the scaling law, that's dictated AI development for quite a while now.
It does. So our mission in this deep dive is to really unpack what's going on here, the technical stuff that makes this possible, look into the controversies and challenges it's already facing, and then kind of zoom out. Understand the bigger picture, the implications for AI development for the industry, and yeah, even for you, for your daily life. So let's dive right in with this cost thing. DeepSeek it's redefined what's possible, hasn't it? This ultra low cost, high performance combination. I mean, the training cost was reportedly what, $5.576 million, which sounds like a lot, but in this world.
It's remarkably low. And it's not just the money, it's the hardware footprint too, just 2048 specialized computers for training.
Okay, 2048. How does that stack up?
Well, think about Meta's Llama 3. For comparison, that needed 16,384 machines. 16,000.
Wow.
So yeah, this isn't just like a small step, it's a huge leap in efficiency.
That difference in resources is just incredible. And the market impact, the API pricing is what, 1% of GPT-4 Turbo?
1%.
That's not just competitive. It's practically giving it away. It completely democratizes access, doesn't it? Think about startups, developers. They can suddenly build really powerful AI without needing millions in funding.
It shifts the whole landscape. And plus, they've open sourced the models, the code, the training details. That encourages wider access, collaboration.
Which really hits at that core belief you mentioned earlier.
Exactly. DeepSeek directly challenges the traditional scaling law. That whole idea that AI performance has to scale directly with more compute, more parameters, more data.
Right, the bigger is better mantra.
DeepSeek is showing, quite convincingly, that you can get significant, highly competitive performance with dramatically fewer resources. It questions that whole assumption.
So that massive efficiency gain, it makes you wonder, right? What's the technical magic here? How are they pulling this off?
Yeah, it really comes down to some very clever technical innovations. It's not actually magic, it's smart engineering.
Okay, break it down for us.
Well, one of the absolute core elements is its mixture of experts architecture, MOE for short.
Mixture of experts, okay.
So instead of having one gigantic model trying to know everything, imagine a team of specialists. When a task comes in, the system figures out which expert, or maybe a few experts, are the right ones for the job, and it only activates them.
Ah, okay. So it's like routing the question to the right department instead of making the whole company work on it.
Precisely. Take DeepSeek v3. It has, I think, 671 billion parameters total, which is huge.
Yeah.
But it only activates about 37 billion relevant parameters for any given task.
Only 37 billion out of 671.
Right. So you get this drastic boost in computational efficiency. You're not wasting energy firing up parts of the model that aren't needed for that specific query.
That makes so much sense. Like going to a library and getting the specific book you need, not reading the whole building. Does this mean we'll see fewer giant monolithic models in the future? More specialization?
That's a really key question. It certainly seems to push things in that direction. It puts a real premium on clever architecture, not just raw hardware power. And then there's another piece, multi-head latent attention, or MLA.
MLA sounds complex, like a memory upgrade.
Kind of, yeah. Think of it as a smarter memory system. Traditional attention mechanisms, they try to remember almost everything from the conversation or text.
Which gets heavy, memory-wise, right?
Yeah.
Especially with long inputs.
Exactly. It's like trying to recall every single word someone said, even the ums and ahs. MLA is more selective. It compresses the key value cache that's like the model's working memory for the current context.
Okay.
It compresses that by an incredible 93% into a smaller, concentrated latent vector. It filters out the noise, keeps the crucial bits.
93% compression, wow. So it uses way less memory.
Significantly less, which lets it handle longer text more efficiently, and it helps the model focus on what's actually important in the data.
That's really clever. So we've got MOE for specialist routing, MLA for smarter memory. Are there other, maybe smaller optimizations adding up?
Oh, absolutely. They also use things like shared experts.
Shared experts.
Yeah, so some of the experts in the MOE system handle really fundamental knowledge, basic stuff that lots of different tasks might need.
So you don't have like 5 different experts all learning basic grammar separately.
Exactly. It prevents redundant learning. That basic knowledge is handled once, efficiently. It lets the specialized experts focus purely on their unique skills, more efficiency. Then there's node-limited routing.
Okay.
That's more about how the system works across multiple computers in a distributed setup. It minimizes how much data needs to be sent back and forth between the hardware nodes. Less communication, faster computation.
Got it. Reducing the chit-chat between the machines?
Pretty much. And finally, they use the FP8 algorithm. It's a way of storing numbers, the model's parameters, using less space.
Like using a numerical shorthand?
Kind of. It optimizes computation speed and reduces the memory footprint, storing numbers more efficiently while, crucially, maintaining accuracy. It all adds up.
Okay, so MOE, MLA, shared experts, node-limited routing, FP8. It's a whole suite of efficiency techniques. Which begs a question, if these are so good, why haven't we seen them widely used before? Especially by the big players.
Yeah, that's a fair question. It's likely a mix of things. First, some of these technologies, especially really sophisticated MOE, they've only recently matured to the point where you can implement them reliably at this massive scale.
So timing, technology catching up.
Partly. Also, designing and training these architectures is hard. It's complex, takes serious engineering chalks, and maybe, past hardware limitations made it seem easier just to throw more compute at the problem.
The brute force approach.
Right. Plus, for a long time, the main research focus was just raw capability, making the model smarter, bigger, maybe not always prioritizing efficiency to this degree. And, commercial incentives might have leaned towards closed source models where raw power, even if inefficient, was achievable and maybe easier to control than complex open efficiency tricks.
Okay, so DeepSeek's pushing boundaries with tech, but it's not all plain sailing, is it? There's this other side, the controversies, the challenges, the dark side, if you will.
That's right. There are definitely hurdles. One significant one is self-censorship.
Ah, yeah. The China factor.
Like other Chinese AI models, DeepSeek has built-in mechanisms to filter or avoid sensitive topics, politics, certain historical events.
Which could definitely limit how useful it is globally, right? In markets with different expectations about free speech.
Absolutely. It raises big questions about its applicability outside of China or environments with similar controls. Then there are these intellectual property disputes.
Right. I saw reports about data distillation. What's that about?
The accusation is that DeepSeek might have learned, perhaps indirectly, from the outputs of other large models, maybe OpenAI's data, for example.
So basically trained on the answers from another AI.
That's the suggestion. And it raises serious questions about where its data really came from and the IP involved. Even that super low training cost figure, some analysts have questioned if it's entirely accurate or how it was calculated. Adds to the scrutiny.
And isn't there a trademark issue too?
Yeah, apparently another company applied for the DeepSeek trademark in the US before them.
Ouch.
Which could potentially block them from using their own brand name in a major market like the US. That's a big deal for expansion.
And it gets more serious with government actions, bans and scrutiny.
Definitely. Italy and Ireland have banned DeepSeek, citing data security and privacy concerns.
Yeah.
And within the U.S., the Navy, NASA, the Texas government, they've all prohibited its use on their devices.
Yeah.
Taiwan, South Korea, they've also raised questions about its data handling. It just shows how tied up tech innovation is with geopolitics and data sovereignty now.
It's really striking. And despite the high performance marks, there's some catches there too, right? Performance nuances.
Yeah, it's not universally faster or better. Reports suggest it has a slightly slower initial token response time. So the first word might take a fraction longer to appear.
Okay, a slight lag at the start.
And maybe slightly slower overall text generation compared to the very latest models like GPT-4 or Claude. Also, its context window, how much conversation it can remember, is about 130,000 tokens.
Which sounds like a lot.
It is good, but some competitors are now boasting up to 2 million tokens. So for really, really long, complex tasks or conversations, DeepSeek might start to forget earlier parts sooner than some others.
That's a key difference for certain uses.
Mm-hmm.
And the big one for users everywhere, data privacy.
Right. DeepSeek has been noted to transfer user data to China. That obviously raises significant privacy concerns for anyone using it outside of China.
Yeah, definitely something people need to be aware of. It really forces you to think about where your data is going. So DeepSeek's arrival, with all its strengths and controversies, it really shines a light on the bigger picture, doesn't it? The broader battlegrounds in AI.
Absolutely. It forces us to look beyond just this one model and see the larger trends shaping the future of AI.
Like compute, That old saying, he who gains compute gains the world. Still true.
Oh, very much so. Compute remains fundamental, but it's evolving. It's not just about giant cloud data centers anymore. We're seeing major advancements in cloud, yes, but also at the edge, on devices themselves, and even endpoint computing. And then there's the horizon with quantum computing, though that's further out.
Edge computing.
Uh-huh.
You mean AI running directly on my phone or glasses?
Exactly. Processing power right there on your device. It enables real-time AI without sending everything to the cloud. Think of those offline translation gadgets or maybe advanced navigation in your car that works instantly, even with no signal. That's Edge AI.
Why does that matter so much? Privacy, speed.
Both. It keeps your data local, which enhances privacy, and it dramatically reduces latency, the delay, because the thinking happens right there. Crucial for interactions that need to feel instantaneous.
Okay, so compute is evolving. What about algorithms? Are we still just scaling up transformers?
Transformers are still foundational, yes, but they're facing challenges, like running out of high-quality training data. This leads to worries about model collapse if we rely too much on AI-generated synthetic data.
Model collapse. Sounds ominous.
It is. If models train too much on slightly flawed synthetic data, they can start amplifying those flaws, degrading over time, like making photocopies of photocopies. There are also diminishing returns from just making models bigger and bigger, limits to compute power. And the ongoing black box problem, it's still hard to fully understand how these complex models reach their conclusions.
So is progress stalling on algorithms?
Not at all. Actually, what's interesting is that algorithmic advancements seem to be currently outpacing pure hardware improvements. Clever algorithms are finding ways to do more with the compute we already have.
Smarter, not just bigger.
Precisely. Which ties back to DeepSeek's approach, right? Efficiency through smart design.
Okay, compute, algorithms, and then there's the fuel. Data sources. That seems constantly debated.
It's absolutely critical. Issues like data sovereignty, who owns and controls the data correctness, and bias are huge. And these are often tied to national or cultural contexts. What's considered correct data in one place might not be elsewhere.
And the rise of synthetic data you mentioned? Good or bad?
It has potential benefits, definitely.
Wow.
Privacy protection, because you're not using real personal data. It can be generated cheaply, maybe infinitely.
But the risk is that model collapse thing.
That's the big risk.
Yeah.
Over-reliance, especially on lower-quality synthetic data, could lead models down a path of accumulating errors, degrading their own knowledge. It's a tricky balance. How do we ensure data quality and diversity moving forward? Big question.
Moving on to where AI actually gets used. Application scenarios. How is this playing out?
Well, on a personal level, you see it everywhere, right? Prompting assistance, getting help with code, creating content, solving problems. In the enterprise world, we're seeing sort of like 5 levels emerge.
5 levels, okay.
Yeah, starting with basic communication and collaboration, just using AI tools via prompting. Then level 2 is connecting systems via APIs, integrating AI services. Level 3 gets more serious. Fine-tuning models with a company's own proprietary data, usually on private clouds for security.
Making the AI smarter about their specific business.
Exactly. Level 4 is even training localized large models. Like there are efforts in Taiwan to train models specifically on local culture and language to preserve it.
Wow, AI for cultural preservation. That's fascinating.
Isn't it? And level 5 is building whole ecosystems, using multimodal AI text, image, audio for creating diverse content and applications.
And you mentioned robotics earlier as a key battleground. How do things like digital twins fit in?
Robotics is huge. Digital twins are fascinating here. Imagine creating a virtual replica of a robot and its environment. You can then train the robot millions of times in that virtual world to learn a task, like catching a ball. It can fail safely, learn incredibly fast.
And then transfer that learning to the real world.
Often, yes. Once it masters the skill in the simulation, it can frequently perform it almost perfectly in the physical world. It's a way to massively accelerate robot learning beyond what's possible with physical trial and error. We're also seeing AI used at a national level, facial recognition for public services in some countries, smart city projects. It's scaling up.
Which leads to this idea of industry recreation capability. AI isn't just improving industries, it's fundamentally changing them.
Fundamentally, it's set to reshape entire supply chains. It dramatically accelerates the pace of industries. Think about content creation, music.
Yeah, you mentioned albums taking months, now potentially thousands of songs a day.
Exactly. The economic model shift completely, and consumer behavior changes too. Look at the shift from long-form content, like movies, towards short-form video. AI accelerates these trends, changing attention spans, preferences.
The speed is just staggering, and all this change, all this power,
Yeah.
it really highlights the need for guardrails, doesn't it? Policy, ethics.
Urgently needed. Adaptive legal and policy frameworks are crucial. We need ways to address the risks, security, privacy, bias, that self-censorship issue we discussed. It's all about building a trusted, secure digital society as AI becomes more embedded in everything. We need the rules of the road as we're building the superhighways.
So bringing it back to the individual listener, what does all this mean for you? For jobs, skills, the future?
Well, undeniably, AI demands new skills. It changes work processes. Adaptability is going to be absolutely crucial for your generation navigating these new work models. It's less about fearing replacement, more about figuring out collaboration.
And there's some really wild futuristic opportunities too, like this concept of digital twins,
Yeah.
but for people, and maybe passive income from that.
It sounds like sci-fi, but it's becoming plausible. Imagine creating an AI version of yourself.
An AI me.
Yeah. Trained on your knowledge, your writing, your voice, your style. This digital twin could then say, deliver customized lectures based on your expertise, or generate content reflecting your views, even interact in certain contexts.
While the real me is doing something else.
Exactly. It's a way to scale your impact, your knowledge sharing, potentially creating new forms of passive income based on your unique expertise without you having to manually do everything all the time.
That is mind-bending. So if someone listening is intrigued by that, what should they be thinking about now? Collecting their own data.
That's precisely the thought. We'd really encourage you to consider, what unique data do you generate? Your notes, recordings of you speaking, your writings, even just your structured thoughts on subjects you know well. Collecting and organizing this now could be incredibly valuable later for fine-tuning a future AI model to create your own personal or professional digital twin. Think of it as building your unique digital IP.
Fascinating. And looking bigger picture again, building that trusted digital society you mentioned.
It's paramount. It requires digital literacy and good governance at every level, individuals understanding the tech, businesses using it responsibly, governments setting smart rules, suppliers being transparent. It's a collective effort to ensure AI develops ethically and securely. And it makes you wonder, doesn't it? As AI gets better at tasks that require patience or care or maybe even simulating kindness, do we as humans risk neglecting those qualities ourselves?
That's a deep question. What's left that's uniquely human when AI can do so much?
What are the essential human values we need to hold on to cultivate even more? It's something we all need to think about.
So DeepSeek's arrival. It's clearly more than just another AI model. It's a
Yeah.
major disruption, forcing us to rethink the economics, the ethics, the very definition of AI progress. What does intelligence or value even mean when algorithms can achieve so much, apparently, with so little?
Right. And as this powerful AI becomes cheaper and more accessible, how do we make sure it actually enhances human culture, human experience, rather than diminishing it or making it somehow less rich?
A lot to think about.